Okay, let's get into chapter 11, which has to do with solutions. So now we're going to take our liquids and we're going to mix things into make solutions. So what happens when substances are mixed? This is obviously something that you're aware of, that you've probably done before. So let's take 3 glasses of water. I'm going to add a gram of salt to the first one and stir it up. Add 10 drops of oil to the second one, stir it up, and 10 drops of alcohol to the third. What's going to happen? All right, well, the salt will dissolve. So you stir it up and the salt eventually goes away. You can't see the solid anymore. It's totally mixed with the water, so it dissolves. What happens to the oil? Oh, so that's a homogeneous solution. Okay, let's do the oil. We know that oil and water don't mix, and so you're going to see 2 distinct layers. This would be considered non-homogeneous or heterogeneous, I guess, non-homogeneous. And then finally, what happens when you add alcohol? You should see that, again, alcohol dissolves, which again is homogeneous. So they should mix very, very well together. All right, so a soluble substance is one that dissolves to a significant extent in a solvent. So something that is soluble will dissolve. There's, just like anything, there's a wide range of solubilities, which we get into later in the semester, but if something dissolves, we call it soluble. So both salt and alcohol are soluble in water because they totally mix with water. An insoluble substance then is one that does not dissolve to a significant extent in a solvent. It may dissolve very tiny bit. Again, like I said, later in the semester we'll talk about that, but for the most part they don't mix in each other. So oil is considered insoluble in water. And we can also use one more definition. If both the substances happen to be liquid and they mix together, we call them miscible. That means that 2 liquids are soluble in each other. So we could say they're soluble or we could say they're miscible, either one. And then 2 liquids that are not soluble in each other are considered immiscible. So oil and water are immiscible. Okay, so let's look at the definition of a solution. A solution is a homogeneous mixture of 2 or more substances consisting of ions or molecules, and I guess atoms could be considered there too. So in our previous example, both the salt and the water mixture and the alcohol and water mixture are considered solutions. Homogeneous, again, what does homogeneous means? Means that you look at it and every portion of it looks the same or is the same, and so they mix completely. Oil and water don't mix, and so they don't make a solution. And as we saw on the last slide, oil and water are not immiscible. Salt and water and or alcohol and water are considered miscible because they make a solution. All right, well, we tend to think of things dissolving in a liquid, but you can actually have all different types of solutions. So you can have a solution of gases, liquids, or solids, or any combination of the 2. So let's look at some examples. We'll look at them in the next slide. So let's do a few more definitions though. The solute is what is dissolved, the thing that is being dissolved. So in the case of this a solution where you've got a gas or a solid in a liquid, then the gas or solid are considered the solute. If you look back at our examples, the salt is the solute. The oil, well, that's not a solution, and the alcohol is the solute. It's usually the component of lesser amount. The solvent is the thing that is the dissolving medium. What do you dissolve it in? So generally, it's the component of greater amount. So in our salt water solution, water is the solvent. In all 3 of our all the other examples, the alcohol in water, water is considered the solvent. Sometimes it could be the smaller amount, but um, generally speaking, it's the one that's in greater amount. So I guess we'll look at the types of solutions on the next slide. What are some traits of a solution? Well, a solution is by definition homogeneous, meaning it's all consistent throughout. The physical state of the solution is typically the same as whatever the solvent is, although they can be a little bit different. So we'll talk about that later in the chapter. The dissolved solute will not settle out or separate from the solution, even if it's heavier. And so a solution has to stay mixed. So like if you took some dirt and you put it in water, and it's cloudy, eventually some of that dirt will settle out. So that is not considered a solution. That's called a colloid or a suspension, but we're not going to really talk about those. And then finally, the components of a solution are dispersed and consist of a mixture of separate molecules and atoms or ions. So they're totally dispersed, evenly mixed, and consistent throughout. So here are some examples of some solutions. Air is a really easy solution. It's just a bunch of gases mixed together. So both the solute and the solvent are gases. You know, most of air is nitrogen, and then it's got some carbon dioxide, oxygen, probably some chlorine, fluorine, some of those gases at very small amounts. They're all mixed together, and so it is a solution. Soda water is also a solution. This time the solvent is a liquid, usually water in this case, and the solute is a gas. So it's gas dissolved in a liquid, bubbly water. If you take the solute and the solvent are both liquid, for an example, a mixed alcohol drink. So if you put some alcohol in water, it is a two liquids that are completely miscible in each other. Brine or salt water is where you've got a solid dissolved in a liquid. So the solid will dissolve in the liquid completely. And so all three of those are liquid, and the solute are either gas, liquid, or solid. A potassium sodium alloy, that's a real interesting component. Sometimes it's called NaK, sodium potassium. And it's kind of an unusual because both the solute and the solvent, I guess it'd be hard to tell, probably the potassium, a little bit more of the potassium, whichever one's bigger would be the solvent, but one is the solute, one is the solvent. They're both solids, but interestingly, when they mix together, their melting point must lower, and so they become a liquid at room temperature. Let's see, this potassium sodium alloy, I just looked it up, said that it's often used as a coolant for fast reactions. If they give off a lot of heat, they're used as a coolant. Anyway, another solid alloy is liquid mercury in solid silver, used in dental fillings. A gold-silver alloy is a solution of two solids, silver and gold, and this time the solution is solid. If you know, jewelry is usually a alloy of gold and silver, because pure gold is too soft to use in jewelry. Anyway, you can have different solutions made up of different states of matter. For the most part, in this chapter, we're going to focus on liquids being our solvent, and we'll probably look at gases. It could be gas, liquid, or solid dissolved in a liquid like water. So this is some of what I already said. So non-reactive gases can mix in all proportions to give a gaseous solution, sort of like air. Liquid solutions, like I said, are the most common types of solution found in the chemistry lab, and this is what we're going to focus on. So like salt water or soda water or alcohol mixed in water, diluting down something. And then we can have our solid solutions, which are often referred to as alloys. Generally, if they have to both be solids, you might have to melt them first and then mix them and re-solidify them. But here's just some examples of other alloys. So brass is an alloy of copper and zinc, bronze is copper and tin, and pewter is zinc and tin. Okay, so let's talk about the solution process and why are some things soluble and other things are not soluble. So let's go back to our original examples. What if we keep adding, let's go to the alcohol. So what if we add 10 drops of alcohol and it mixes really well with the water? If you keep adding more and more alcohol, you may have done it before. I would say at any level you can mix alcohol and water. You could take your alcohol, add 1 drop of water, and that's a solution. Or you could take a cup of water and add 1 drop of alcohol. So alcohol and water will mix at all proportions. Oil and water will never mix. No matter what you do, you could keep adding oil all day and it will just keep getting a bigger layer on top. So oil and water will never mix. The alcohol and water will always mix at any proportion. But the salt now, there will be sort of a point where it'll stop dissolving. So like if I add a teaspoon of salt and stir, it'll probably dissolve. If I add another teaspoon of salt to the water, it'll probably dissolve. But if I keep adding salt and keep adding salt, eventually I get to a limit where no more salt will dissolve. And so all of these show kind of the 3 different, kind of the wide spectrum of what happens. So often there's a limit to how much solute will dissolve at a given temperature and pressure. So say we're mixing the salt in the water. At the point where the salt stops dissolving, it has reached its sort of maximum. That's referred to as its solubility. How much salt can dissolve in water? What's its solubility? So an unsaturated solution is one that has less solute than what's allowed at stated temperature. So like I said, if you add 1 teaspoon of salt to the water and it totally dissolves, that's probably considered an unsaturated solution because you can still add more. It hasn't reached its limit yet. A saturated solution then is one that's holding as much solute as is allowed. So I can keep adding salt, and then at the point where no more salt will dissolve and I have some sort of sitting on the bottom of the cup, I have created a saturated solution because the water has absorbed as much salt as possible and it can't absorb any more. Now again, at the stated temperature, because you probably realize that sometimes you can heat it up and put more in, but we're not talking about that yet. This is at a particular temperature. So here, sort of what I was talking about. So it turns out that the solubility of salt is 36 grams of sodium chloride in 100 milliliters of water. So if I take 30 grams of sodium chloride up here in the top picture, 30 grams, and I mix it in there, and it will all completely dissolve. And this is considered an unsaturated solution because I could still add more. It doesn't have the maximum amount dissolved in the water. Now in the second example, you can see I have 40 grams of sodium chloride, which is above the saturated. So you put that 40 grams in there, what's going to happen? 36 grams are going to dissolve, and the additional 4 grams that can't dissolve will just sit on the bottom. So a lot of times if you want to know if you have a saturated solution, you want to make sure that you have some solid still sitting at the bottom, because that means it has dissolved as much as it possibly can. So this is a saturated solution. We also can sometimes have what's called a supersaturated solution. A supersaturated solution is one that contains more solute than is allowed at a given temperature. And we just got through saying, well, it can't hold more than that. So what are we how do we get this? Well, the key is temperature. So, and if you've ever made rock candy or anything like that, you've created a supersaturated solution. So what you can do is you can, like, say you were making the rock candy, you can heat the water up. Now at hotter temperatures, more salt, or probably for candy, more sugar can dissolve. Then when you cool it back down to room temperature, if it doesn't come out of solution, that's considered a supersaturated solution. It's kind of like it's very unstable, as this says. It won't hang around forever. Eventually, whatever's excess in the solution will come out of solution, which is how you get rock candy. So it's unstable, and sometimes just shaking it up will cause all the excess solute to come out. Or sometimes you can put a small seed crystal, like just a tiny crystal, or just touch it with a pointer or something like that, and what it does is it gives a structure to the solute, and it will crystallize out. I have a video. So here's where just before we added the seed crystal, it was completely clear and colorless, and they added that, and this crystal formed. If you're interested, you can watch this video, crystallization of a supersaturated solution of sodium acetate. I can't do that now, but you can go to this and watch the supersaturated solution. Then when the crystal comes back out, it's going back down to saturated.